Hey, Dr. Pat here, looking at linear functions word problems we'll be playing with. Now, if you've got a word problem approach and it's working for you, keep on using it. But if you don't have one, I've got 5 simple steps right here. Step number 1, identify that goal. Basically, if you've been in a math class, the typical math question works like this. Starts off with a bunch of information, go to the last sentence, because that's usually where you're finding the actual question itself. And so, identify that goal, go to that last question, find out what we're trying to find. And then, in step number 2, I go through that problem, start listing my information, and since I know what my goal is, I can then list my information in a way that's making sense, and sometimes I can list information and determine whether it's good or bad or just extra information. Step number 3, also list any related formulas you might be thinking of. So this is the thing that actually some research has looked at for people who are experienced or experts in the field. One of the things that they've noticed is their ability to be able to bring information from previous problems using that experience. And that's one of those things, is really bringing in those related formulas and stuff like that, making those mental connections. So that experience, very important. Number 4, do the work. Yeah, you got to solve that equation. You got to evaluate all that good stuff. Do that work. And then number 5, check that answer. Gotta be honest. Number 5, I'm a little bit lazy. Number 5 is not always something that I've done, and usually it ends up embarrassing me by either lower grades on scores on tests, or when making a presentation and I didn't check my answers, and now I'm fumbling around trying to figure out how I got that wrong and how I am supposed to correct it. Okay, so number 5, kind of important. Let's look at our first word problem here. Timmy goes to the fair with $40. Each ride costs $2. How much money will he have left after riding N rides? Okay, so we're looking for a dollar value. In the end, it's going to be a dollar value. So how much money? N rides. And because I don't have a specific number of rides, that's telling me I'm not going to be able to kind of rationalize it through. I'm going to have to come up with a formula. So this is telling me coming up with a formula. So my goal is to see how much cash he's got. I'm using the letter C for the cash for N rides. N represents in the parentheses what my formula is going to entail. Okay, so my information that I've got to list is each ride costs $2. So that means in terms of Timmy here, that's going to reduce the amount of money he has in his pocket. And so that's why it's going to be a negative, and it's $2 per ride. So that's slope. Slope is that per word. So I'm rephrasing this saying $2 per ride. Per means slope for me. And then the other pieces of information that we have goes with $40. That means how much cash he has. He has $40 to begin with. That also means the data point 0, 40 for 0 rides, $40. That's kind of like our fixed cost, or if you're doing a business example. And so I'm using the formula M times N plus B. And so M here represents slope. N is the variable, kind of like the X. And so B is that y-intercept, that initial value. So let's just plug our numbers in. We've got our slope. We can plug that in. We've got our initial value. That's what it means to be at time 0, or quantity 0, or number 0. X is 0. This is your B value automatically. So I bring that down for B. And here is my formula. Starting off with $40, losing $2 for each ride. Okay, so there's an example of a word problem. Nice straightforward one. 3-sentence word problem. Not too bad. Okay, let's get into a more involved one now. Okay, blah, 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 blah. What I'm doing is I'm cheating. I'm going to the end and I'm looking for what I'm supposed to do. I'm supposed to write an equation, and they want to use P of T, not the letter Y, but P of T, not using X, using the letter T. So that's where we've got P of T. And then T is years after 2005. So that's important. So when I go through my information, I'm going to list it in a way knowing that T is in terms of years after 2005. All right, so that's what we got to do. Write an equation. That's what I'm shooting for. I'm going to use a formula. That's what my goal is with T in it. That's my goal. All right, so what information? Oh, look at right there. Linear was one of the key words in that very first sentence. That means that formula that I want to make, it's going to be MT plus B. That's what we're using. So instead of X, I'm using T here. So that's my goal, make this formula. To make that formula, I better have some information to find M and to find B. And so my first piece of information that I read is 2005, 69,000. Well, wait a minute. If we're talking about years after 2005, then 2005 itself is the year 0. And so I've got the data point 0, 69,000. Okay, my next data point is, or a piece of information, excuse me, not a data point, but a piece of information is the population has been growing by 2,500 people each year. So that's 2,500 people per year. You know what? That's my slope. So automatically I got a slope of 2,500. All right, so let's put this information together now. Slope of 2,500, a data point of 0, 69,000, and I'm trying to make the formula MT plus B. Well, let's plug that slope in, and then because this is the data point 0, 69,000, that's my initial value, that's my B value, and so let's put those in, and there's our formula. Our goal was to make the formula, and it was linear, and using the information, we're able to put it in and get our formula. So thanks. Have a good day. Take care.